As we launch into our graphing unit, we're going to review graphing linear equations. So first of all, what's a linear function? Well, it's anything that can be written in the form of y equals mx plus b. You should know that your slope is represented by m in this equation, and the y-intercept is represented by b. Remember that your slope is rise over run. It can be positive if it's uphill, downhill is negative, zero slope is horizontal, and an undefined slope is vertical. So again, I said linear functions can be written in this form. Now there is another linear equation, like x equals 2 is a line, but it's not a function. This is a vertical case with an undefined slope, which means it's of course not a function. Let's look at some examples. So this first one is y equals 3x minus 2, and we're asked to find the domain, range, slope, and then our intercept. So this one is already in slope-intercept form. So my y-intercept is negative 2. I'm going to place that on the graph, and then I'm going to count up 3 and write 1 because my slope is 3. Now remember, sometimes it's easier to write it as a fraction, and you count up and to the right. And you do it again, up and to the right. You could also go down 3 and 1 to the left. Connect it to make your straight line. Okay, we are also asked to name the y-intercept. It's negative 2. Now the x-intercept, that's where you let y be 0. You're letting the opposite letter. So that would give me 0 equals 3x minus 2. So I'm going to add 2 to both sides, gives me 2 equals 3x, and then I divide by 3 and I get that x is 2/3. So remember that 0 is another word for the x-intercept. As a point, it would be 2/3, comma 0. Okay, the domain. Well, for all linear functions, the domain would be all real numbers, because this graph would go forever to the left. It keeps moving left and it keeps moving to the right. So using the symbol for all real numbers. Similarly, the range, it goes forever down and forever up, so the range is also all real numbers. Let's graph y equals 3x minus 2 on the calculator. So 3, remember x comma t comma theta comma n, minus 2. I'm going to hit zoom 6 to see my standard viewing window. And let's talk about how to get the y-intercept first, since that's easiest. To get the y-intercept, you just hit the trace button. These values appear at the bottom, and typically by default, it goes to the y-intercept. See, 0, negative 2 is right here. But if it wouldn't, you can type any value you want. So you let x be 0, hit 0, and enter, and it will tell you your y-intercept. To get the x-intercept, it's a little more complicated. You're going to hit second trace. You're going to select option 2 to find a 0. Remember, a 0 is synonymous with an x-intercept, so choose option 2. You're going to be asked 3 questions. Left bound, see down here, and then it'll say right bound and guess. And here's the idea. Your 0 is right here on the x-axis. You need to be to the left of where that occurs, which means you're going to be a little bit below. So I'm going to move this closer and hit enter, and now it says right bound. It drew this vertical line to show me that it's putting a boundary, a left boundary on it. Now I'm above where the 0 occurs, and it says right bound. I hit enter, and now the calculator is just saying, do you want to guess? And if you can see, it's going to find the 0 that occurs between these two lines, vertical lines. So I hit enter a 3rd time, and here I can see what my 0 is. Now, I will not accept 0.6 repeating as your 0. You must know that 0.6 repeating is the same as 2/3. So if you struggle with math concepts like that, then you still need to be able to do it the old-fashioned way, where you plug in 0 for your function and solve it to get 2/3. All right, so x equals 3. I had taught you the acronym VUX. Remember Hoy and VUX. So vertical undefined slope is in the form of x equals 3. So if x is fixed at 3, no matter what y is, I have this vertical line, x equals 3. So when I look at this, my y-intercept, it does not exist because it never crosses the y-axis. My x-intercept is the point 3, 0. My slope is undefined because it's vertical. As far as domain and range, this one's just ever so slightly different. My domain here, the only x value that's included is 3. So my domain is x equals 3. My range, however, this one is all real numbers because it goes forever up and down. This next one here is in standard form. So we could change it to slope-intercept, but I'm going to remind you of how we could do this by just finding my x and my y-intercepts. So to find my y, if I cover up the x, meaning if I just cross it out, I would have negative 4y equals 20. And then I divide by negative 4 and I get y equals 5. So my y-intercept is 5, or the point 0.05. My x-intercept would be, of course, where I let y be 0. So if I let y be 0, that gives me 5x equals negative 20. Divide both sides by 5, and I get x equals negative 4. So this is the point negative 4, 0. So from here, I could try counting my slope at this point, or I could change it to slope-intercept form. I'm just going to see from this point, it goes up 1, 2, 3, 4, 5 units, and to the right 4. So my slope is positive 5 over 4. Both my domain and range would be all real numbers because lines go forever to the left, forever to the right. It's also going up and down infinitely. Okay, this one, when it's one letter, hoi, this is going to be a horizontal line, 0 slope, y equals negative 2. This one's easier to see because if you do y equals mx plus b, you could see, well, there is no x, so that must mean the coefficient is 0, and my y-intercept is negative 2. So I'm going to have a horizontal line through negative 2. So my y-intercept as a point would be 0, negative 2. The x-intercept does not exist. It doesn't cross the x-axis. I already said my slope is 0. And then again, my domain and range will be all real numbers. In 5, this is in neither slope-intercept nor standard form, so I'm going to choose to solve this for y. And since y is already on the right, I am going to leave it there and begin by subtracting 10 from each side, which would give me 3x minus 12 equals 4y. Now I'm going to divide both sides by 4, which would give me 3/4 x minus 3 is equal to y. So my slope would be the 3/4, and my y-intercept, my b value, is negative 3. As a point, it would be 0, negative 3. So it crosses the y-axis at negative 3, and I'm going to count up 3 and to the right 4. I could go down 3 and left 4 as well to get another point here. And I can easily see my x-intercept just by looking at the graph right here. It is 4, 0. And when we talk domain and range, again, they're both all real numbers. The last one, I'm going to begin by dividing both sides by 3, which gives me y equals negative 2x plus 3 to change it to slope-intercept form. So I see that my slope is negative 2. I'm going to begin by making that a fraction. My y-intercept would be the point 0.03. My x-intercept is where I let y be 0. So if I add 2x to both sides, I get 2x equals 3. Divide by 2, and I get x equals 3/2, or 1.5. As a point, that would be 3/2, 0. So I can go right to 1.5, 0. Put a point here. I can put a point at 0.3. I can also count my slope from my y-intercept of down to right 1, down to right 1. And there I've got a bunch of points that I can connect. Domain and range, again, would both be all real numbers.